So then the next slide is just a comment on how to solve the tripartite stuff. You have like 7, for example, 7x, 7 times x, 7x greater than 2 minus 4x greater or equal to minus 5 plus x. So basically you solve them separately. You solve 7x greater than 2 minus 4x, and you also solve 2 minus 4x greater or equal than minus 5 plus x. It's like break it up into 2 problems. And then you're going to find the solution for both of them. And then you'll find the intersection of those solutions.
So the interval notation is just how we write the answer
Right.
to what we solved. And then the tripartite inequalities are, I'm not
like 2 problems in one. It's just like
okay.
Yeah, it's just like I have one inequality here and I have another inequality here. So I need to solve this one and this one.
Okay.
So I'll break them. Yeah, I repeat the middle part and then I break them into 2 parts and then solve them separately. And then try to find the numbers that fit both solutions.
So here, 7x is greater than 2 minus 4x is one part. And then I'm not understanding where they're divided or like where there's multiple.
So we have 7x greater than 2 minus 4x is the first 2 parts, right?
Okay. Mm-hmm.
And then the second 2 parts are the middle part and the third part. So I have 2 minus 4x greater or equal than minus 5 plus x.
Okay.
Right. And hopefully I chose a part. So the second part we just solved. It was the previous slides.
Mm-hmm.
Right? Because I was trying to build up on the example, so I have to solve it again. So we already know, I said, we already know that the solution set for 2 minus 4x greater or equal than minus 5 plus x is 7/5 to infinity, because that's the one we just solved.
Okay.
So now we have to solve the new one, which is 7x greater than 2 minus 4x. Yes, is everybody with me? Can we go back 2 slides, please, Ben, so that they can see that 2 minus 4x was what we had here. 2 minus 4x greater or equal than minus 5 plus x was the one we just solved.
Okay.
And we discovered that the solution is x smaller, what's happening? X smaller or equal than 7/5. So I wrote it wrong, right? My notation. Wait, sorry. X has to be smaller. Sorry. Mistake. X needs to be smaller or equal than 7/5. Oh, this is bad. I need to change everything. So wait, it's here. Can I get the whiteboard? I messed it up. It's like here, 7/5 greater than x, right? So here my solution should be x can be smaller or equal than 7/5. So it should be negative infinity to 7/5 bracket. Like this. This is the actual solution. Yeah, the one I have on the slide is wrong. I'll correct that. Yeah, and then I don't know though, because the recording will have the wrong notation. But this is the actual notation for this. Yeah. But we have solved it, so I don't have to solve that again. I just have to remember that the solution set is actually negative infinity to 7/5. So now we solve for the other one, the other part. We have the next one. So we have next one. Let's solve 7x greater than 2 minus 4x. So again, I try to move everything that has x to one side and everything has numbers on one side. So I'm adding 4x to both sides. That gives me 7x plus 4x. That's 11x. And then the negative 4x and the plus 4x cancel each other out. So I have 11x greater than 2, right? And then I divide everybody by 11. So then x is greater than 2 11s. So in interval notation, it's parentheses, 2 divided by 11 and infinity. Yeah. Okay, then going back to the whiteboard.
Why is there no bracket on this one?
Because it's greater than 2 11s. It cannot be equal to 2 over 11.
Oh, okay.
Yeah, and then going back to the So what, ooh, on one side I had negative infinitive to 7/5, right? That's one set I could. And then the other one is open to 11 to infinity like this, right? So this is
And-
what we used to do. When I was a student, I would do it like this because at least it helped me. I don't know if it's going to help you. I'll have a 0 here. And I'll draw them on the line like this. Like numbers going up, always going to the right-hand side. Yeah. So from 7/5, let's say 7/5 is here. And then X could be all these numbers here that are smaller, right? Here. And then 2/11 is somewhere here. And X could be greater. So I need to find something that, you know, that is a solution here and also a solution here. So the only set I have is this one. So my solution set is going to be 2 divided by 11 to 7/5. The intersection, yeah. I should have typed this. I want the intersection of the two solution sets.
And this kind of thing is the thing that is wanted on the project.
What's on the project is not like this. What's on the project is you will have maybe like the graph of a function, and then you have to say, you have to show the domain. So for most cases, you're going to have negative infinity to infinity for most cases, but not always. No.
Okay.
It's not about solving equations. The project is about graphing functions, and they will ask you to represent the values that X can take in interval notation. But I don't know if it's clear that it has to be the intersection of the two sets because my X needs to be here and here at the same time so that the tripartite thing works. Yeah, it's like I want a rich guy and a tall guy. So I'm going to pick rich and tall, right? I need both. So it's kind of like not one or the other. So for the both, then you're going to have a smaller set because you're restricting it more. Yeah, okay.